Hey everyone, Geophysicist Stefan Burns here. We have yet another solar storm that's launched out from the sun in the general direction of Earth that's expected to impact to some degree over the next few days. This is from Sunspot Group 4465. You see it right there. That was a long duration 6.7 C-class flare, so the third strongest category out of 5. Not an M-class flare, not an X-class flare. Those are the biggest. But it did launch out a significant coronal mass ejection. We see that here with our coronagraph imagery. You see the bulk of the plasma is going to the east solar coordinate system, also skewed a little bit to the north. So this looks just like the other solar storms that have launched out recently, where you get this halo signature, but at least for the other two, the impacts are quite weak. And so this could be another situation like that where we're getting a little bit of a fake out. We'll just have to wait and see. Here we see our angle from stereo A. So we're looking at Earth effectively from the side. Earth would be right over here. So we do see that this is a pretty nice coronal mass ejection going out. And again, you see it slightly skewed there to the north of the ecliptic plane, but certainly it is also along that ecliptic plane. So the big question is going to be just how Earth direct is it? We see our NOAA space weather model here for this event, and we see it following up, catching that earlier coronal mass ejection and hitting us with a flank impact. This is our top-down view. That's the Earth, that's the sun. This is our south-north view right here. You see that's nicely aligned with the ecliptic plane. You will also notice that we have a high-speed stream here already impacting Earth. It's happening right now. The impact has just started as I record this. You see that this comes in with a higher velocity and bumps the velocity up even higher for the solar wind. So they're expecting solar wind to get up to about 600 kilometers per second. It should get to that range due to the high-speed stream, and then it bumping even over 700 kilometers per second as a result of this coronal mass ejection. Now we can look at this coronal hole that has caused this coronal hole high-speed stream impact, which we have just started right now. So we see it right here. This is a very long-lived coronal hole that's been on the sun for more than 10 times. It's been like, I think, 12 plus rotations at a minimum. And this last rotation was very, very large. Now, before I show you that, what is a coronal hole? It's an area in the solar corona, the outermost atmosphere of the sun, which is made up of super high temperature plasma, many millions of degrees Kelvin. So like 2, 3, 4 million degrees Kelvin. Super high energy, low density, and very, very bright. It releases a lot of photonic energy, right? Light photons, which we receive 8.3 minutes later. We image this with extreme ultraviolet and also soft X-ray light imaging sensors. So you can't see this with your naked eye. You have to see this from space effectively, because most of this energy gets absorbed into our own ionosphere, our uppermost charge atmosphere, which has about 1% plasma. So when it's dark, that's a deficiency of plasma. And what has happened since its last rotation, which I can show you right here, and you'll really see just how much it has changed from its last rotation, is that we have a lot more sunspots now, and this coronal hole is really closed up. So you notice that there's this big spur off to the north. It's quite a bit bigger in terms of its transequatorial portion. And also, and you'll notice the date there, this is May, okay? You'll also notice these two other mini coronal holes here in the southern hemisphere. Okay, so those can be your markers. You'll see that also in our most recent imagery, which I'll go back to, really highlighting the fact that this is the same coronal hole. You see that spur there, but it's greatly diminished in size. But this is important to point out because A, we're right now at the beginning of this coronal hole high-speed stream impact. So we're looking at elevated geomagnetic volatility going forward. We have this new coronal mass ejection coming in. Again, we can see the differential chronograph imagery for that here. We'll get hit by some sort of shock wave. We certainly have some sort of shock wave coming in, but it does look like it's not going to be a direct hit, and that's the story that we've been seeing with the other ones. We'll go through that data to really lay it out clearly. But over the next few days, we are going to be having heightened geomagnetic activity, and these coronal holes are well correlated, like super well correlated. I think it's causal, but you do your own research. Super well correlated with the big earthquake activity that we've had for 2025 and 2026. And that is notable because this solar cycle 25, has been unusual in the fact that it's been dominated by these large trans-equatorial coronal holes. They've been much bigger than this, especially last year. This one has just shrunk quite a bit. You see these launches also with our imagery here. So you see we had one there, we had one pop off there. There's been quite a bit happening over the past few days. And so we're in quite a bit of solar wind turbulence at this moment in time. I can show you the solar wind observations for this moment in time right now. Here we see it. NOAA has just made Solar 1 data available. This is our new probe that's about 1% of the distance from the Earth to the Sun. It's our advanced warning effectively for space weather. And this is the latest technology, so it's really cool to see this. But we see our coronal hole high-speed stream come in here. Before we really analyze this data in depth, let me just show you what this looks like. Here's a graphic of a coronal hole high-speed stream. So there's a coronal hole. You see this plasma coming out like a sheet. It goes off in a spiral fashion like this, okay? Sweeps all the way out. You have low density, high velocity plasma that makes it the majority of a high-speed stream. But because inevitably the high velocity plasma catches up to something slower, you form this high density co-rotating interaction region. And that's slower and you get this pile up to occur. But once that passes, because it does have velocity, it's not completely stationary. Once it passes by the Earth, then we'll enter into this low density, high velocity stream. And this is when these big earthquakes appear to pop off. And that's notable because right now we have quite a few zones on the Earth that are displaying increased seismicity. We're having tons of aftershocks from the magnitude 7.8 that struck the Philippines. And we also have an antipodal zone for that location in Chile, in the Peru-Chile Subduction Trench, that's looking quite active. And that's where we had the magnitude 6.9 recently, also a magnitude 6, this location being in the center of that. So we could be looking at some big earthquakes correlated with this coronal hole high-speed stream impact like we've been seeing now for months. Not just once or twice, but over and over and over and over. So that is what's happening right now. We go back to our Solar 1 data here. And while you see the velocity starting to go up, if I put my cursor over this, you can see where we are. We reached a peak of 475 kilometers per second. Right now we're about 460. But look at the density. It's at about 15 particles per cubic centimeter, but it even spiked up to 23. That's really high. And our solar wind field strength is quite high. So we're at 12.9 right now and negative 12.21. It just flipped southward. Let's zoom in on that. So if this maintains a nice BZ, a negative BZ configuration for some time, that means we're going to ramp up in geomagnetic activity quite quickly. We see our KP index down here, a measure of this activity with Earth's magnetic field, the big swings in field strength, primarily concentrated to the high latitude regions, North Pole, South Pole, but also extends out across the planet. But with the velocity increasing, the density behind, and also the BZ having a southward configuration, that's really what we need to drive a pretty significant geomagnetic storm. And then as we go into a low density stream and the velocity is really high up there, we're probably going to get hit by that shock wave from that other coronal mass ejection, and maybe we start to get these earthquakes to pop off. So let me show you just some of the other things that have happened recently. Here is the 1.8 M-class flare that occurred on the sun that just gave us a minor shock wave impact, okay? And NOAA was estimating a G3 storm from this, and we got nothing like it. So it's important to keep these forecasts, create a little distance between these forecasts from the different agencies from me, right? I thought this was going to be a little bit bigger than just nothing, effectively. Well, that's what happens. We really didn't have much. Here we see that impact come in. So clearly the magnetic field jumped up, going from about 6 nanotesla up to 10 or so, but you see that it didn't trigger any geomagnetic activity. And the velocity was weak. Basically, most of it went away from the Earth and didn't interact with us. And as we can see here, it went mostly to the south and to the east. we can see what this looked like with our stereo ahead imagery. So this can kind of help us ground truth what we have coming in. There it is on stereo A. So again, you see it mostly to the south and to the east, okay? But mostly with this view, we can just see the north or south inclination to it. Well, I don't have a good chronograph imagery for this other sequence that we had that did drive some activity earlier in June, but this was a combination of a 3.3 M-class flare, a 9.3 M-class flare, a 7.7 M-class flare, and then a 1.0 X-class flare. And this hit us back at the beginning of June, as you may recall. This combined with a coronal whole height speed stream, and it only triggered a G2 geomagnetic storm for 3 hours, and then we had G1 activity on either sides of that. But you see them going off there, here, here. So that first one's nice. Some of these others are clearly going to the north, but the estimate for this was G3 with isolated periods of G4. And well, what do we get? We got a G2 storm right here. And we do see that the solar wind velocity spiked up quite a bit. I mean, it went all the way to, I think this is like 700 kilometers per second. Density was fairly good at 27 particles per cubic centimeter. And the field strength went up to about 20 nanotels, a little bit less than that. But we only got a G2 geomagnetic storm because we didn't have any super sustained southward component. And we only got clipped by all this activity. So when we get these sort of forecasts for geomagnetic activity from these explosions on the sun that launch out coronal mass ejections, it's good to look at all the different angles for them, the chronograph imagery, the stereo head imagery, also think about the strength of the solar flare that occurred, and the current solar wind conditions. This one definitely looks like the most direct shot of the 3 examples I've shown you, but this is only a long duration 6.7 C-class flare. So it's really not a big flare at all. And you'll notice that before that, we did have this puff of dark plasma that was emitted from the sun. You see that right there. Let me go back one more time for you on that. So watch right there. There's that puff of plasma. That's not really expected to impact us. That's coming in from like negative 25 degrees here. But you'll see that this sunspot group, which launched this, and you see the canyon of fire that right there, that launched out this coronal mass ejection a little bit skewed to the west. That's why it's more closely interacting with us than you would think based off its degree. It's only at like negative 45 or so. Now that sunspot though, as you can tell, is rotating to Earth center and direct. So we will have this sunspot to deal with over the next few days. And well, this is actually a pretty significant sunspot. We can check it out here with our magnetogram view, our 4K magnetogram, and it's a reverse polarity sunspot. So we have a very big, powerful, positive magnetic core there. You can even see the texturing on it, and you'll see this also with the intensitygram of how this just descends into the depths of the sun. These sunspots actually are these magnetic vortices down into the sun. It's really interesting. But we see that we have here negative polarity leading in front of this positive polarity, and that's typically what you don't see in this solar cycle for this solar hemisphere. If we switch over to our other one, here we see it. So a lot of that magnetic flux is buried just beneath the surface because we don't have these super obvious sunspots like this core surrounding it, but we do see that magnetic flux. And if we go back, here we see the overall sun, and you'll see this opposite polarity. So we do have a big sunspot here right now, by the way. Keep that in mind. This guy could pop off at any moment. But 4465 right there has a flip polarity. And you can see it very clearly. Southern hemisphere has negative leading, positive behind. Negative leading, positive behind. Negative leading, positive behind. Negative leading, positive behind. Keep in mind that is southern hemisphere. It's right below the equator, okay? That's the polarity convention for solar cycle 25 for the southern hemisphere. It's going to be the opposite for the northern hemisphere. What do we see here? Well, we see positive and negative right there. That's normal, but we've had actually quite a few sunspots that are weird. This one's a bit odd because you have it just actually vertical and you have this negative polarity almost in front of it. So that's a bit bizarre. We had a reverse polarity sunspot rotate off just a few days ago, and now we have 4465 here also with this mixed polarity. And you can see the sheer extent of that though again, a lot of that is buried just below the surface. We're not seeing super obvious cores for that. So here's the story. We have this solar storm impact coming in. We don't know exactly how strong it's going to be, but we know that it's going to hit us at least something, because we see that very clearly with our stereo A imagery, with our coronagraph imagery. We saw the direction it launched out with our just direct solar imagery. We are already in a coronal hole high-speed stream impact at the very beginning. That's going to drive geomagnetic activity at least to a G1 level. It'd be pretty shocking for it to not even drive G1 activity. It's been fairly regular with doing that. Again, it's been on the sun for like a dozen plus rotations. And this is all happening when we've been in greatly elevated seismic activity for the globe. So we have all the combinations lining up for the middle of June to be quite dynamic. That potential is quite high. Does not mean it's going to happen, but it is quite high. Here we see our USGS latest earthquakes, and this is the earthquake swarm that struck the Philippines, okay? So we see our magnitude 7.8 there, a 9 on the did you feel it? And there are videos of giant cracks opening up in the ground for this, intense shaking. This is very destructive, and it was a deadly earthquake. Well, we see 67 earthquakes here in this map area, a few off to the side. But if I just go like that, that will get it 63. And if we sort this by highest magnitude, you see 7.8, 6.5, 6, 6, 5.8. And look at how many 5s there are. Tons of magnitude 5s there. Look at that. Tons of magnitude 5. At least like 24 magnitude 5 earthquakes. So this was a big earthquake that's still releasing a ton of energy seismically. And well, the other location that we've been seeing heightened activity is South America with Peru and Chile, and specifically this subduction trench, which gives us the most powerful earthquakes on Earth, at least based on our observed record. That's primarily from the magnitude 9.5 1960, strongest earthquake to ever strike as far as we know. Though I'm sure other big earthquakes like that have struck elsewhere, but this is a nice big subduction trench with a big kink in it, and that's what you need to generate the biggest earthquakes. So here though, we see this 6.9 right there. That's on the 25th of May. Then we see on the 31st of May, a magnitude 6. That's all preceding what happened in the Philippines, mind you. So that's important to note. And now look down here. We see these 3 earthquakes, 5.1, 5.2, 5.5, and we sort this by newest. You see it's the same order. So in fact, the magnitude's been increasing. These are in between, effectively, these 2 locations, as we can see here, right? And there's also magnitude 4 earthquakes that are occurring in this zone as well. Let me show you that. Here's our magnitude 4 quakes that we can see very clearly with volcano discovery. They have a different latest earthquakes map that you can look at that includes more sources. USGS doesn't list everything, by the way. And here we see those other magnitude 4s. So this, for example, 4.5, 4.4, 47 minutes ago, 4.1, 4.3. So, you know, this is just like a preliminary sign that we could get something bigger there, not guaranteed, but that is pretty common foreshock activity before, let's say, like a magnitude 6.5. Usually be 1 magnitude higher or more. Now, if we go to our super tunnel app, so we can see the antipode, I've already marked here Santos City for the Philippines. Our antipode is right there in the middle of South America. Now, these antipodal quakes, where they ping back and forth, are not exactly on the antipode because there's mostly refraction of how these seismic waves move through the core and the mantle of the Earth. And so, well, where's that subduction zone? And where's this area that we're watching? Right here, super close to the antipode. This is where we had the 6.9. That 6.1 also just further showing seismic activity there. And now after this 7.8, we're getting these magnitude 5s to pop off in between those 2 events. So, I mean, if I really had to put like a bet down, and if there is a high magnitude earthquake to occur over the next week or maybe like 7 to 10 days because of the space weather being a factor that just tips things over the edge, of course, you know, earthquakes happen because there is strain that accumulates from plate tectonics and other geologic forces that eventually ruptures. But what is the thing that maybe causes the rupture to occur? You need there to be a critical stress that is hit, and then that rupture happens. And space weather can do that. There's other things that can also basically knock the dominoes over. But we see here already antipodal activity with the 6.9, the 7.8. We could see a middle magnitude or even high magnitude 7 for South America in the next few days or coming weeks. And that would actually make a lot of sense because we've had tons of magnitude 7 activity in the Ring of Fire for the Western Pacific for the past 18 months, 24 months. We really haven't seen much for South America the past 18 months. So there is this imbalance. So keep that in mind. If we go to here, our global seismic activity level, also provided by Volcano Discovery, we see this interval here caused by this coronal hole that we've been tracking. So here we see the global seismic burst that occurred end of March, beginning of April. That was right when we had the coronal hole high-speed stream connecting to us. Then we see this activity right here. Then we had it also here. It was not as significant as these prior episodes, but you see it clearly lined up with the solar rotation period, about 28 days. And this one here also happening during a coronal hole high-speed stream impact as well. A different coronal hole, that was a positive polarity coronal hole, the other ones are negative polarity. Well, we're coming right back up to the next rotation, and well, we're just now interacting with that coronal hole high-speed stream. So today, Thursday, all the way through the weekend, even a couple days afterwards, it's all fair game. So one more thing just to talk about is that in general, we see a lot of geomagnetic activity in our recent time frame. This is 500 years of space weather storms with aurora visible at or equatorward of 30 degrees magnetic latitude. So these are the big boys, all right? Well, we don't see anything during the moderate minimum. I mean, we have this one there, 1730, but moderate minimum ended around 1715. It's 1645, 1715, no sunspots, basically no activity. We could be coming up to another grand solar minimum. That is certainly possible, but we'll have to wait and see with solar cycle 25 to be over. If solar cycle 26 doesn't happen, then we know we're in one. If we have solar cycle 26, then we know we have to wait another 11 years effectively. But you see that they're quite regular here because this is the modern maximum period which we've been in. You see the Carrington event right there, 1859, 17 degrees, 20 degrees, magnetic latitude. There's others that have gone lower. Okay, so you'll see some here, for example, 1921, 16 degrees. This is just aurora. It's not the only thing that matters for a strong solar storm impact, these sort of Carrington events or near Carrington events. But look at this, 1909, 1938, 1921, 1940. I mean, they're all over the place. Then you have this gap here, 1989, we talked about that in yesterday's live stream. 2024 with the Gannon storm, also known as the Mother's Day storm, May 10th to the 12th, 2024, right? Well, we haven't had really anything for a while. And so it's very possible that we get some big solar storm impacts in the near future. And looking at some of the data and long-term forecasting, things that I can look at for 2026 and beginning 2027, I think it's very possible. It looks very likely. So I'll talk about that more in a separate video because it looks actually kind of serious. But I think at the end of the day, we'll be fine. The question is, will the satellites be fine? Will the telecommunications be fine? Will the power grids be fine? That's an open question. Do we want them to be fine? Not everyone wants these data centers to get put in. But as of right now, we have this coronal hole high-speed stream impact underway. We're going to be entering into increased geomagnetic volatility. These swings in Earth's magnetic field strength inducing electric currents in the ground surface. There's a reverse piezoelectric effect where electric currents can trigger mechanical deformation of rocks, minerals, inducing stress and building up strain. We're seeing strong earthquake activity still in the Philippines after the magnitude 7.8. We're seeing reciprocal antipodal earthquake activity in South America on either side of that now. So we could be looking at more big earthquakes in the days ahead. And we have a solar storm impact to some degree following up behind that, coming in expected on the 13th of June is when NOAA is expecting this most recent solar storm that's launched off from that 6.7 C-class flare to hit us. So a lot happening. I will keep you up to date on everything. I've been your host, Stefan Burns. Thank you all so much for watching. Smash that thumbs up button, help the channel grow. Subscribe to stay up to date on everything that's happening with the Earth energetically, earthquakes, volcanoes, space weather, solar activity, planetary alignments and resonances, and geometry, interstellar cosmic forces, and more. I cover it all. Thank you all so much. Wishing each and every single one of you well. Please take care of yourselves. We have this energy coming in. Make sure you just treat yourself a little better than normal. Ground, rest, eat good food, drink good water. Lay off the things that perturb your body a little bit, like alcohol, coffee. Always smart things to do. Wishing you the best, and I'll see you all in the next video.